Hello everybody. In this video I want to show you how to navigate a little bit with the cheat sheet. And it was a little bit overwhelming to see everything, and actually we are going to see some of this part. We are not going to see everything from the file. I believe we are going to see around 40%, but I just want to teach you a little bit how to navigate through the page, try to understand a simple concepts. But in reality I want to focus in the arithmetic operation. What kind of operation we can do in Python, and what are the different outcomes that games or results for those specific operations. So let's begin. As you can see, I have my cheat sheet open to the left, to the right, and my Visual Studio Code open to the left. I have programming my Visual Studio Code to be running every 2 seconds my arithmetic file. So it doesn't matter right now. It's just for showing purposes and to save a little bit for time in order to show results in the console. But if I do something like print hello there, and I save it, it's going to be automatically executed. If I do name equal Rodolfo, hello there, plus name, is going to be executed. So it's just refreshing the execution of the specific file. This is only for showing purposes. So let's begin. We already see some type of variables. Actually, we saw that everything that we put through the console in Python is a string and need to be casted. That means that need to be changed to another one. And the basic example that we can see over here are the conversions. So for future reference, please see the conversion section to see what type of conversion you can do in a specific file, more likely in the top level. So let me zoom in a little bit and let's see this part. So how the conversion works is actually writing the type and then the expression. In this case, let's say 15. The integer of 15 is actually 15. You will see probably there is not that much case in here, but because we have 15 between double quotes, that means this is a string. And if this is a string, we cannot do operation with that. Let me show you an example. So let's say we have number 1 equal to 10, and we have number, wow, I cannot type right now, sorry for that, equal to 5. What is the difference here? If we print number 1, comma, number 2, we'll see 10 and 5 over there. But what about we want to add them? We will have an error because there is unsupported operand adding an integer and a string, because the 5 it doesn't take it as a string. So this is actually the same as an input. Whenever we put an input, it always saves as a string. That's why we need to convert it or cast it to the type that we actually need. So if we do this, we have the operation. So we are converting the number 2 as a string to integer. We can actually cast specific integer number based on the second parameter. So in this case, let me show you this. and let's print it. What is happening here is casting 3SF as base 16. So 3SF base 16 converting to integer or decimal is 63. I don't know if you're familiar with those numbers. They use a different type of numeric. There is a different numeric notations. The most common and the one that we use on a daily basis is actually base 10. So every time we see an increment or we see like a movement through the numeric. We have binaries, that's only 1 and 0. We have octal, and we have hexadecimal. So this is actually hexadecimal. We say the base is hexadecimal, converting to integer, and it gives you 63. Just to have a simpler case, 10 to 16 is 16, 11 is 17, and go on. So the way that this actually happens is we have 1 is 1, we have 9 is going to be 9, A is going to be 10, F is going to be 15, and that's why 10 is actually 16. So the name go from 1 to 9, and then go on with A, B, C till the F. And when you reach F, you start over. That's the basics, it actually how it works. And here we are converting a base 16 character to integer. That's why we have the proper conversion. Yeah, there you go. Also, it helps us convert another, not only strings, but another characters. In this case, let me just print it in order to have the output there. Give me the integer part of 15.56. We also can to float, and one specific one really cool in the rounded. So sometimes we had a example something really big number. Let me just copy this one. Oh, good move, sorry for that. Let me just copy this one, let me print it, and let's say that we have a really big number in there. So we are rounded the number to 1 digit. So if we have 54 here, it's 5, it's only give 1 decimal because it's the one that we are specifying actually. But if we go to 55, it's round up to 1 decimal. This is jumped to the next one. So the rounding, what it does, it actually helps us to see how many decimals we want to do. We go to do 2, we see it's rounded to 2 decimal. If we do 0, it's pretty much doing, it's rounding without decimal in there. So we can actually have rounded to have a specific number, be rounded to the more integer. This is actually really helpful when we want to, we have a really big divisions, example, and give it like a lot of decimals in there, and we want to round it to one specific one. And we have another one like characters and representative and bytes, and this is a little more complex, and we are not going to enter in those one, but I want to give you the basic one. It's actually to specific integers, to specific float, and how to run a specific number. Now, this is the main section of the conversions. Let's go to the math section. It's on the bottom left of the first page. So we have our basic operation here. Let me just, and actually we just take the first one, that is a simple addition. We already did one. We have a rest, we can do that too. So let me copy this one. In this case, it's going to be 5. 10 minus 5 is 5. This is going to be a 4. 10 minus 4 is 6. So we say that it is actually working. We have the multiplication. That is pretty much self-explanatory. The multiplication is always with a star. So 10 by 4 is 40. We see it over there. And we can see the operations that we need to write in Python and what it means in the bottom sections. We have the division. .5. We can actually round it if we want it to 0 decimals. And I did something here. Oh, I'm missing a parenthesis. There you go. Wait, you're not here. Oh yes, you are. No, sorry, it's here. There you go. So we're dividing and rounding to specific decimal. Let me just remove that section and leave it just the division by itself. It's really important to get track of the different parentheses and where they are. As you can see right now, I have color code parentheses. This is going to be for the Visual Studio guys. The one to actually install it is go to the extensions and look for Rainbow, I believe it's called. Rainbow. Let me look at my list. This one, bracket per colorizer. What it does is actually just give you different colors. It's going to be easy to detect, but parentheses depends from another parenthesis. That's pretty much what it does. So you just look for bracket per colorizer is going to handle that. This is all the version 1. There's another one called 2. Probably it works the same, but it's, as you can see, it has less downloads. So let's go with the 1 to 3 millions, and it's the official one. Then remove this. Okay, let's continue. We have the integer section of the division, and this is a really good one. So we know that number 1 divided by number 2, in this case 10 by 4, will give you 2.5. But if we do the double division like that, it's going to be 2. But if we do the remainder of the modulus, it's going to give us 2. So this is give you the integral part of division, and this will give you the remainder that we have. So in this case, 10 divided by 4 is how can I show it a little bit more? Let me just open let's open just something really quick to actually show you. So we have 10 Whoa. Let's do this. We have number 10 and we need to divide it by 4. This is what it does. It's actually, let me just increase a little bit. So 10 divided by 4, we have pretty much 2. 2 by 4 is 8. And be really explicit over here just to show something. And the total is going to be 2. So something like that. So the double operations that we have over here, it gives you the integer sections, and the modulus is giving it just the remainder. Let me just reorder this. Better. So let's have another different number over here. So if we let's copy over. If we want to divide 11, so it's going to be 2 by 8 is 8, 2 by 4 is 8, and remove that 4, 11 is going to be 3. So if we change our number to 11, we will have the integer section as 2 and the remainder as 3. This is going to be as 2 and this is going to be a 3. Let's save it, and here you go. Let me delete, or let me actually just comment those out so it will. Okay. So the common divide gives us the whole decimal process. The double character or double forward slash will give you the integer section, and the modules give you the actual remainder. It's what it actually this is saying from over here. Okay. Then we have the power section. That means that this one print 2 by is going to be 8. Because this is 2 by 2 by 2, it's 3 times. We do it 4, it's 16. So the power it's represented with double stars. So this is actually the same as 2 elevated at the 4 power, and we can actually work it like that. So this is actually the way that we need to see the different sections of the cheat sheet, and we can get that specific part and implement it in where we want it. We actually have another more complex one, and I want to just show you a little bit section of this and how to use the number pi. So we know that pi is actually equal to 3.1592 something. I don't remember the whole number. But to be a little bit more precise, Python have a math library that we can use. But the math library is not imported by default in our applications. So we need actually to put it there. And to put the math library, we do need to say from the math library import pi. Just remember that what we're doing is import a specific function from the math library. Let me just comment this out, and we can say something as print pi. And here you go. Well, I give you 1592, it was actually 14. Sorry for that. So in this way we have pi integrated, and we can do another kind of operation like the seal and the floor. So we can do seal pi. Oh, we need to import it. We cannot do seal pi. Well, we can do seal 3.55. Oh, sorry. We need to print it. That's why it's not there. And we can do floor pi. And let's print it in order to see it. And we need to import it. So seals is round the number to the next level, it doesn't matter what is the decimal, and floor round it down to the lower level, depending what we actually want to have it. And these are the basic math operations. I hope that you enjoyed the video. See you in the next one.